All right, guys, number 22. I know that this is a type of problem that has caused some confusion, I guess, for some students over the years, and really, it's probably more so. I would say, in my opinion, it's less to do with what's actually going on, more to just do with the size of the problem. Again, how how is it that mistakes are made? Well, when you're doing 50 different steps, that's just going to be potential to drop a sign or add two numbers incorrectly or something like that. The more steps you have, the more opportunity for error. And I think that that's, if you have struggled with these problems, again, back in Chapter 7 or through the review over the last week or so, I would be willing to guess that that probably had factored in. There's also the possibility of setting up this system that, again, if we miss there, it doesn't matter if you're perfect with the math. If we messed up the original setup of the equations, that's going to lead to a problem. So again, we want to be conscientious of all that stuff as we're setting up and solving this problem. So number 22, it says that a small corporation borrowed $45,000 to expand its business. Some of the money was borrowed at 7%, 9%, and 11%. How much was borrowed at each rate if the annual interest owed was $3,950 and the amount borrowed at 9% was twice as much as the amount borrowed at 11%? Okay, so I'm a business owner and I need to borrow $45,000. When I go to the lenders, when I go to the bank, they're not willing to give me $45,000. They're saying, okay, we'll give you X amount, but you got to pay us back 7% at the end of the year. Okay, I'll take it. Well, I need to get up to $45,000, so now I go to the next lender. How much are you going to give me? We'll give you Y, but you got to pay us back 9% at the end of the year. Okay, all right, I'm still not at my goal yet, so I go to the last place. Can you give me this final amount? Yeah, we'll give you Z dollars, but you're going to have to pay us back 11% at the end of the year. So I know that total amount that I'm going to have to pay back at the end of the year is $3,950. Okay, so I think it's probably wise for us to identify the variables. So I'm going to just use X, Y, and Z. And I'm going to let X be the amount of money that was borrowed at that first 7%. Y is going to be the amount borrowed at that 9% rate. And Z is the amount borrowed at the 11%. So fortunately, what tends to happen in these types of problems is usually one of the equations of the system is really easy to find. So the first one is that we're borrowing a total of $45,000. So X plus Y plus Z, that's going to be $45,000. Okay, now once again, we don't know how much we're borrowing from the first place. We're going to call it X. We don't know how much we're going to borrow, but we have to pay back 7% at the end of the year. Same thing with the second business. We don't know how much we're borrowing. We're borrowing Y, but we're going to have to pay back 9% at the end of the year. And the third, we're borrowing Z dollars, and we're going to have to pay back 11% for a grand total of $3,900. All right, does everybody understand why I'm calling this 0.07, not just 7x? Because it's a percentage, right? Okay, so now the last piece. This is where some students, again, thinking back to Chapter 7, some students struggle a little bit. It says that the amount borrowed at 9%, so that's what we've been calling X, was twice as much as the amount borrowed at 11%, which is what we were calling Z. So right now, this is untrue. Y does not equal Z. Right now, currently, the amount that we're borrowing at Y, this right here, is twice as much as that. So again, think something like 10 compared to 5. If we need to make these balanced, we've got two choices. I could divide 10 by 2, or I could multiply 5 by 2, right? So same thing over here with the Y and the Z. I'm not interested in bringing in a fraction and saying y over 2 or 1/2 y, when I could just do this and say y is equal to 2z. Now again, not to say that if you wrote this up as y over 2 equals z, you're still going to be successful. You could do this. It's just, I'm looking at it from the standpoint that we already have decimals. Why would I bring fractions into this too? Or if we called it 0.5y or something like that. Again, we already have enough other types of numbers going on. Why not use integers when we can use integers, is my humble opinion. All right, so we typically want to put these in standard form. So if I were to subtract the 2z over, we're going to call that y minus 2z equals 0. And this is now my system. So in the traditional sense, the way that we would go about solving a system of 3 equations and 3 variables is that we would use elimination, and we're going to target one variable and eliminate it 2 different ways. What that translates to is that we're going to try to take 3 variables, 3 equations, and get it down to 2 variables, 2 equations. Usually, again, we use elimination. This problem is a little unique in that we know that y is equal to 2z. So could I go back into my first and second equations and plug 2z in place for y? Could we do that? Could I rewrite this top line? Just rewrite it as x plus y plus z equals $45,000. But instead of y, can I put 2z in its place? Are we now down to 2 variables? Yeah, we can do the same thing in the second. 0.07x plus 0.09y, what we're saying is 2z, plus 0.11z equals 3,950. And we now have 2 variables, 2 equation system. Now, yeah, we have to clean it up a little bit, but the structure is there. Okay, so in cleaning this up, top equation is going to be a little bit easier. We have x plus, what's 2z plus z? 3z equals 45,000. All right, now with your help here, that second, we've already got the 0.07x. But go with me on this though. What do I get when I take 0.09 times 2z? It's going to be 0.18z. Agree on that? Now if I'm going to add 0.11z, what's my total? We have 0.29z equals 3,950. And this is the system that we're going to go ahead and solve. All right, now question for you. We have options. Could we right now, directly the way that this sits, could we go ahead and use elimination, eliminate the x's, and make this happen? If I wanted to eliminate the x's, what would I multiply the top equation by? Negative 0.07, and we could do it, and it would work out nicely. But do we have anybody in here who's looking at this and saying, man, I really wish we didn't have decimals down there? Okay, if you don't want to raise your hand, I'll say it. I wish we didn't have decimals down there. Could I just multiply this bottom equation through by 100? Say top equation is x plus 3z equals 45,000 still. But now my bottom equation is 7x plus 29z equals 395,000. Now, again, totally optional step. But some of us are going to feel much better looking at this as compared to what we were looking at with all the decimals. Again, your call. Now we're going to multiply the top equation through by a -7 to set this up. Again, top equation is now negative 7x minus 21. Z, I don't know what I was trying to draw there. 21z equals negative 315,000. Second equation stays at 7x plus 29z equals 395,000. And the beauty of the elimination method is that the x's do exactly that. They eliminate the cancel, they're gone. Now we have 8z equals 80,000, which means z has to equal how much, please? So z is going to be 10,000. 1 down, 2 to go. Now typically, in a system of equations, as soon as we solve for z, we would have gone back to this secondary and plugged in for z here or here to solve for x. And please don't let me sway you the wrong way. You could still do it that way. I just think that going back to the beginning, we said that y equals 2z. We kind of hung our hat on that fact. And that's going to be a lot easier for us to calculate y. If we now know that z is 10,000 and y is 2 times z, or 2 times 10,000, what does y equal, please? Y is going to be 20,000. Okay? Also, the very first thing that we said, all the way back at the beginning, was that we were going to borrow a grand total of $45,000. So if y plus z is 20,000 plus 10,000, 30,000, how much must x have been? It's got to be that remaining 15,000. Right? So guys, that's how this problem is going to work. Now, again, the pre-calc teacher in me wants to stay away from it, but realistically, remember, it's a multiple choice test. We could use that to our advantage. Please don't go into that thinking, oh, sweet, I don't have to do any of the actual work. I just have to warn you, it's designed in a way to where that might not be your best option. You're going to have to do some systems work in order to pull that off. Okay? But again, you could narrow some answer choices real quick. All right, guys, let's take a look at number 23. Number 23, it says that we want to find the minimum and the maximum values. Now, Is this the one? Am I remembering correctly? You were not given a graph on this. Sorry, you really should have had a graph on this one. Tomorrow on the test, you'll be given scratch paper and graph paper. I just, again, there are ways to do this problem without graphing, but it involves like solving 4 systems of equations, which you don't want to do. We have to know where the vertices are located. Once we know where the vertices are located, then we can plug them back into the objective function. Without the vertices, the objective function is essentially worthless. So let's go ahead and figure out what's going on here. The nice thing is that this isn't the whole drawn out process. We're given the constraints. We're given the objective function. Again, the long drawn out process would have required you to find all of that. Here's the word problem. Let's set up and do the whole thing. If you remember what we prepped for on the performance part, you're doing that whole entire thing to where you read through the situation and you're going to have to create the objective function and create the constraints. But you get to stop there. This is basically just like picking up where you left off. Does that make sense? So between the performance and the multiple choice, you're doing an entire linear programming problem. It's not the same problem. It's not a continuous deal. But that's kind of where we're at with this. So the nice thing, once again, is that we're given everything that we need to a point. But right here, when I'm looking at my constraints, are you guys okay with me just telling you what the graphical form is going to be? Okay, I should probably get to the correct problem, though. What number is this, 23? All right, so I've got that the graphical form is going to be y less than or equal to negative x plus 5. My 4th constraint, I've got y less than or equal to negative 1/2 x plus 3. All right, so let's go ahead and graph these. X is greater than or equal to 0, y is greater than or equal to 0. That's going to force us to stay in the first quadrant. So we're looking at this. My 3rd constraint, y less than or equal to negative x plus 5. I'm at 1, 2, 5. My slope is negative 1. Solid line, of course. Looking at something like this. My 4th constraint, y-intercept is at 3. Slope is negative 1/2. All right, solid line again. Also make sure that you guys have a straight edge. To speed up the process, you good with me just telling you about the shading? All of these is going to shade toward the origin. This is going to be our shaded region. Once we know the shaded region, then we can identify the vertices. And that's crucial to this whole problem. We're going to have vertices in these locations. The reason why the vertices, of course, are so critical, is that now we know what we're going to be plugging into the objective function. So when I plug 0, 0 into the objective function, remember, that's literally, I'm going to put 0 in for x and a 0 in for y. When we do that, we're going to get that z is 0. Next up, I've got a vertex at 0, 3. So 0 in for x, 3 in for y, 0 minus 3. That tells me that z is going to be negative 3. Next up, my vertex is at 4, 1. Put a 4 in place. 2 times 4 is 8, minus 1 tells us that z is 7. And then lastly, we're at 5, 0. Again, put a 5 in place for x. 2 times 5 is 10, minus 0 is going to stay at 10. Our job on number 23 was to find the minimum and the maximum of the objective function. So what's the minimum, please? 0, negative 3, 7, 10. Which one's the smallest? Negative 3 is going to be the smallest, right? So my minimum is equal to negative 3, but it's also important that we know where that's happening at. That's happening at 0, 3. What about the maximum? Largest value was 10. So my maximum is going to be 10. And where does that happen, please? At 5, 0. Kind of blends in, sorry, but you get the idea, I hope. Nathan. Into the objective function. Oh, right. Okay. On this type of problem, yeah, it just gives you the objective function for sure. All right, guys, let me stop the video here. I'm curious to see if you guys could do number 26 on your own. Go ahead and give that one a shot real fast while I'm uploading this video real quick.